Hello students, very good morning. Okay, good. Today we are going to see about the revisions of September monthly test. In this lesson of magnetism and magnetic effect of electric current, we have only discussed about or revised about a very important topic related about above a monthly test. First of all, we know that elaborately we see the lessons of magnetism. What do you mean by magnetism and how they are classified, and then after what are the fields will be used with the help of the magnetism. First of all, we have discussed about the very important topics of magnetic elements. There are three elements are seeing there in this lessons. First of all, magnetic declination. Second one, magnetic tip or inclination, indicated capital I. And third one, the horizontal component of earth magnetic field. These are the three important components of magnetic field. And then the first important questions and repeated questions also asked in our monthly test. It may be, what do you mean by magnetic dipole moment? Already we have discussed in earlier of first lesson electrostatic electric dipole moment. In this lesson we are see about only through the magnetic field. So in this questions asked frequently, define magnetic dipole moment and it give its unit. So we know that magnetic dipole moment is defined as the product of its pole strength and magnetic length, and its unit is denoted by, we know that, magnetic pole strength and then after distance. So it tells us on this unit Newton ampere per meter square. And types of magnet. Basically magnets are classified in two types, namely natural magnet and artificial magnet. So natural magnet is they have not in a regular shape. They magnetic strength is very small quantity. An artificial magnet having higher strength and also having a regular shape. It may be rectangular, square, circular, or its U shape. And then important two more questions. Define or state Coulomb inverse square law. This is most important questions for this lesson. The same process of first lesson. The Coulomb inverse square law states that the product of the magnetic poles is directly proportional to the force and inversely proportional to the square of the distance between them. This is the Coulomb inverse square law. And then repeated 5 more questions. Magnetic field at along the axial line of the magnetic dipole or ball magnet. First of all, we draw the diagram neatly and explain the components related. What do you mean by S and what do you mean by N, what do you mean by O, and how they are separated a particular distance. What do you mean by QMC at point C? So we are tells us elaborately. Then after, to find the magnetic strength due to the polarity of north pole and south pole, we provide of two equations, and adding both the equations we get the axial line of the magnetic inductions. The similar way, and one more important 5 more questions. Magnetic field along the equatorial line. The same process. First of all, we discussed the axial line. What is the magnetic induction due to the axial line? In this session we have discussed what is the magnetic induction along its equatorial line. So draw the diagram neatly and explain about the components related through the diagram, and find the magnetic force due to the two polarities respectively north pole and south pole. So adding this two component, we get the equations of magnetic induction of a resultant force So finally we get the value of magnetic induction due to the equatorial line. Okay, good. And important 3 more questions, it may be asked frequently in 3 more questions also, and also 5 more questions. Torque acting on a bow magnet in a uniform magnetic field. The same process. Draw the diagram neatly. There are two forces acting along north directions, and then after south direction. It may be north polarity and south polarity. And adding these two equations, we get the torque forces. So tau equal to PMB sine theta. And example 3.7 is important calculations oriented questions. It may be asked. Then after, potential energy of a bow magnet in a uniform magnetic field. Tangent galvanometer is neglected because of this is our practical oriented. Then after, important 2 more questions. What do you mean by magnetic permeability and magnetic susceptibility? This are the 2 questions are very repeated questions, and also having in our book back. And classifications of magnetic materials. Magnetic materials are classified in 3 types, namely diamagnetic material, paramagnetic material, and ferromagnetic material. The 3 types of magnetic materials are having different properties. It may be similar to dia to para to ferro. So we are study the properties of dia and para and ferromagnetic materials. And also, what do you mean by Curie's law? This is the important 2 more questions. It may be asked. The susceptibility is inversely proportional to the Curie temperature or temperature. This is Curie's law. It may be asked the September monthly question for your exam. And then important 5 more questions, hypothesis. In these 5 more questions also included with 2 more questions. It may be what do you mean by causivity, then what do you mean by returnativity. The 2 questions are asked in frequently. And then important most repeated questions, Bayes-Savart law. It may be asked 3 mark or 5 mark questions. Bayes-Savart law explains, tells us the magnetic field through the conductor. This law tells us magnetic induction is directly proportional to the current and length of the element and sine of the angle between the length of the element GL and R cap, and inversely proportional to the square of the distance between them. This is the Bayes-Savart law. So explain elaborately these questions. And important 5 more questions. Magnetic field due to long straight current carrying conductor. Draw the diagram neatly and explain about the diagram oriented content, and find the value of magnetic induction at a point P. So we get the equations of B vector equal to mu naught I by 2A. This is the final value. And then one more important 5 more questions. Magnetic field produced along the axis of the current carrying circular coil. First of all, we had the value of straight current carrying conductor. In these questions are related about magnetic induction through the circular coil. And next, magnetic, this is an book back questions also. Magnetic dipole moment of revolving electron. In this questions contains many 1 mark questions included in the 5 mark questions. So we just read the questions thoroughly, and also getting 2 more questions also. What do you mean by gyromagnetic ratio? Find the value of gyromagnetic ratio. These are this 1 mark questions it may be asked. And then Ampere's circular law. In third lesson, the Ampere's circular law is most important questions. So Ampere's circular law tells us The line integral of a magnetic field over a closed loop is mu naught times net current enclosed by the loop. So just read the questions thoroughly. And also one of the most important questions, magnetic field due to the current carrying wire by using of Ampere circuital law. And this question is very simple to understanding about Ampere circuital law. And then solenoid. What do you mean by solenoid? Find the value of solenoid inside of the solenoid and outside of the solenoid. And to find the magnetic induction due to the current carrying solenoid, this is the 5-mark questions it may be asked. And then after toroid, find the magnetic induction of the toroid and Lorentz force or Lorentz force. Lorentz force is asked in 3 more questions. Lorentz force is nothing but whereas F vector equal to Q into V vector cross B vector. In asking it may be explain the properties of magnetic rotor force. And then the most important questions of 5-mark and repeated questions to asking cyclotron. Frequently asked questions, cyclotron, we draw the diagram neatly, and what is the aim of cyclotron, and what is the principle and construction working process and limitations of the cyclotron device. These are the questions containing the answers. So read the cyclotron questions very carefully, because of this question will be asked frequently for a government examination. And then one more questions, force on a current carrying conductor placed in a magnetic field. This is asked in 3 more questions or 5 more questions. And this is the important 5 more questions. Force between two long parallel current carrying conductor. Draw the diagram neatly and find the value of B1 and find the value of same way df, and applying the value of f by L to find the value of once again B2. Substitute the value of B1 and B2, find to the force and getting the equations. And then moving coil galvanometer. This is the important 2 more questions. Sensitivity of a galvanometer. Sensitivity of a galvanometer is nothing but a galvanometer is said to be sensitive. It gets a large deflections when we are passing a small amount of current. The galvanometer get a large deflection. This is called as sensitivity. In case of we are providing large amount of current, the device gets damaged because of the galvanometer just needed a small amount of current. So this is called as sensitivity of a galvanometer. Here current sensitivity of a galvanometer is defined as the deflection produced per current flowing through it. And it may be asking the knowledge based questions, how we increase the current sensitivity of a galvanometer. So we write thus by increasing of number of turns, by increasing of magnetic induction and the area of the coil, and inversely proportional to the decreasing of couple per unit twist. And one more 2 more questions. What do you mean by voltage sensitivity? The same value. Voltage sensitivity of a galvanometer is nothing but deflection produced per unit voltage. And finally we are going to see about the last topic and most important topic also, conversions of galvanometer into voltmeter and conversion of galvanometer into ammeter. We know that galvanometer is a device which is used to measure the deflections of current or measuring the flow of current. So we are going to change the galvanometer into ammeter and we are going to change the galvanometer into voltmeter. The first process, conversions of G to A, which means galvanometer into ammeter by connecting of low resistance to parallel to the circuit. This is called as the conversions of galvanometer into ammeter. The similar way we can connect the high resistance to the galvanometer with series combination. So the galvanometer converted into voltmeter. These are the conversions of galvanometer into ammeter and galvanometer into voltmeter. A simple way, already we have discussed very elaborately. These are the important topics to go to see and study about the September monthly test. So be careful and study well and prepare very well to your September monthly examination. Wish you very all the best. Thank you.